So today I'll be talking about solubility rules and how to use it when dealing with any precipitation reactions or net ionic equations. When first introduced to solubility, it may look intimidating, but I promise you it's not. The reason the table is set up in this specific order is because some rules are more important than others based on their priority. So our first rule, we have alkali metals such as lithium, sodium, and potassium, as well as cesium and rubidium, which I included here on the right. And we also have ammonium, which are going to always be soluble no matter what. So always soluble just means that there's no exceptions. So this rule's first because it's one of the most important rules and it's always going to override any of the others. Our next rule, we have nitrate and acetate, which again is also soluble. And over here on the right, I included how acetate can also be shown as CH3COO to the negative charge. And some students do not know this and they get confused when they see acetate written in this form on any exams. So I just felt it was important to include. I also included another rule below right here that states chlorate and perchlorate are always soluble as well. Our next rule, we have a few halogens right here. We have chlorine, bromine, and iodine, which are always soluble with any ion except silver, mercury with a 2 subscript, or lead with a +2 charge. It's also very important when looking at any reactions to notice what charges they may have. So if lead did not have a +2 charge, then it would be considered soluble if it was with bromine, iodine, or chlorine. Our next rule, we have sulfate, which is soluble with all ions except all of these listed right here. Again, you can see they have specific charges to them, so pay attention to that when dealing with any equations. Our next rule, we have carbonate and phosphate, which is soluble with our rule 1, but insoluble with any other ion. And lastly, we have OH- and S2-, which is soluble with all of these right here, but insoluble with any other ion. So now moving down here, I wanted to explain what soluble means. So soluble is just a way to say aqueous, and aqueous just means that it would be dissolved when put in any water. So we'll always use AQ to state something is aqueous. And then insoluble just means that it will turn into a solid when added to any water, and we'll just use an S. And even slightly soluble still stands for being a solid, so we just use an S. So here I added a few examples to practice. So here we have silver nitrate, and looking at our solubility rules, we see right here rule number 2 that nitrate is always soluble. So since Ag has a plus charge here, that means that it would be aqueous and it would dissociate into Ag plus and NO3 minus when put in any water. Our next problem, we have H2S. If we come up here, our last rule, we see that it is insoluble with any other ions except these right here. So it would just be solid with no dissociation. So we just leave it as is. Our last 2 problems, we have barium sulfate. If we come up here, we see it is soluble with all ions except right here, barium. And we know that there's a 2 charge here because the 2 from sulfate is not right here. But if it was, then this would just mean that the barium had a plus charge. So that means that it would not dissociate and it would be a solid. And then we have lithium phosphate, and coming up here, it is soluble with lithium. So it would be aqueous. So it would be Li plus PO4 3-. And those are just a few examples to help you practice with the solubility rules. And in our next video, we'll get into precipitation reactions and net ionic equations.